Hi all, our first topic is cryoscopy. Here we are going to discuss how cryoscopy helps in determining the molecular weight of a polymer. We all know that the freezing point of a solvent is lowered when a non-volatile solute is dissolved in it. This lowering in freezing point is known as depression in freezing point. In general, the solution freezes at a temperature lower than that at which the pure solvent do. For example, water freezes at 0 degrees Celsius, but when some amount of salt is dissolved in it, it freezes at a temperature lower than 0 degrees Celsius. The cryoscopic technique is based on this phenomenon of depression in freezing point by the addition of a non-volatile solute. The extent of freezing point depression depends on the number of solute molecules dissolved per unit volume of solution and is independent of the size and nature of solute molecules. The freezing point depression depends on the number of solute molecules. That is, when the cryoscopic method is applied to determine the molecular weight of polymers, we get number average molecular weight Mn bar. Here is the equation: delta Tf by C equals RTf square by rho delta Hf into 1 by Mn bar plus Bc. Here delta Tf is the depression in freezing point, C is the concentration of solution, Tf is the freezing point of solvent, R is universal gas constant, rho is the density of solvent, and B is a constant called second virial coefficient, and delta Hf is the heat of fusion of solvent. Now let's discuss about the experimental method. The freezing points of pure solvent and of very dilute solutions of the polymer sample in different concentrations are determined using standard freezing point technique or cryoscopic technique. One of the method is the solvent or solution is supercooled to a temperature that is about 5 degrees Celsius lower than the freezing point. The supercooled liquid, when stirred, starts freezing rapidly with a rise in temperature, which attains maximum and then drops down. The maximum temperature attained is the freezing point of the liquid. This line indicates the freezing point of a solvent. And when some amount of solute is added, the freezing point of solution is lowered. This line indicates the freezing point of solution. And the difference in freezing point is called delta Tf, depression in freezing point. And once the freezing points of solvent and solutions of different concentrations are known, delta Tf can be calculated for all these concentrations. Using this data, a graph of delta Tf versus C is plotted and extrapolated to infinite dilution, that is 0 concentration. This point indicates 0 concentration, and from the value of ordinate intercept of the plot at 0 concentration, Mn can be computed from the equation delta Tf by C, where C tends to 0, equals RTf square by rho delta Hf into 1 by Mn bar. ഇത് നേരത്തെ തന്ന ഇക്വേഷനിൽ when C tends to 0, the term Bc can be neglected. And from this equation, the number average molecular weight Mn bar can be calculated. And next is the limitations of cryoscopic technique. And the main drawback of this method is the measurement of temperature. The temperature difference between the freezing points of solvent and solution may be of the order of 0.001 degrees Celsius. Hence, it needs high precision temperature sensors. By the advent of thermistors and high amplifying electronic devices, now temperature changes as small as 0.0001 degrees Celsius can be measured with precision. And another inherent limitation is that the measurement of molecular weight beyond a certain figure starts becoming unreliable. It can be explained from this equation as mn bar the molecular weight increases, the depression in freezing point delta Tf becomes smaller and smaller value, which becomes difficult to measure with accuracy. Therefore, by this technique, molecular weight up to 30,000 can be determined accurately. And beyond this molecular weight, other methods like vapor phase osmometry can be used. Thank you.